something really fun, shall we? Depends what you mean by is. Depends what you mean by being, correct? Zeno. Practical part of Zeno. Elia. Elia is where? Parmenides and Zeno are in the same school of thought. Yeah, they have. So this is before the very first university was Plato's Academy. Prior to that, you had little schools, like little, almost like clubs that would be around the. Yeah, little cults. Some of them actually were cults, like Pythagoras and
education.
Yeah, they were strange. They did ceremonies. Well, they sacrificed male virgins. No, I'm kidding. That always kind of sounds funny. Yeah. Bringing out the male virgin to be sacrificed. They were doing geomancy, magic with numbers. Yeah. Isn't that crazy? They were actually. Well, they actually, yeah, they thought some weird stuff.
Are they in the weird culture?
Yeah, they're in your, absolutely, they're in, look up Pythagoras, the Pythagorean cult.
Yeah, we even try to read it.
Yeah, you know what's funny? I need to bring my friend in. I call him the magician logician. Wouldn't that make lectures so much better if when I was lecturing I could just like birds would like fire and good idea, thank you for sharing that. I'll incorporate magic into my lectures. I should bring my friend Ken in because he does some great magic. And he ties it into philosophy because it's all about deception. It's like, what did you just buy into that made you think that this was happened the way it did? Because you know it's like, that cannot be. Okay, I'll hold off. I just met with him, so I want to. That's a great idea. Okay, Zeno is famous for paradoxical motion. They believe, just like, because they're in the same school, that all reality is one. Now, if all reality is one, suppose that I say this is place A. I'm standing and pointing to place A. And this is point B. In order for me to move from one place to another, don't they have to be in different places? If I said, hey, watch me move. You didn't move, you stayed in the same place. So in order for there to be motion, there must be difference of place. A must be different from B in terms of place, so that now I'm leaving one place and I'm moving to the next place. Because if it turns out that A and B are the same place, then I haven't moved anywhere. But if everything is one, there is no difference in place. And therefore motion is an illusion. It's not real. Now, going back to the categories of, well, do they fit into rationalists or more the empiricist? Well, they would be rationalists because they'd say, you better not bet on your senses. Why? Because your senses, remember the rubber pen, are constantly deceiving you. Or if I took an apple, I said, look at this. I walk out 800 yards, And it's like, wow, it shrank. And then I came back. Well, that's what your senses are telling you, that the apple's getting smaller. Is it really getting smaller? How do you explain that it looks like it's getting smaller?
It is moving from moving away from you.
Yeah. So you have to use, and explain in terms of, or a portion, or if I put this pen into a glass of water, oh wow, it's now bent. Is that true? That's what your senses are telling you, but you would use your rational mind to correct that in terms of light refraction. That it's giving the illusion that this is what they would say. It looks like things are moving, but your senses tell you all kinds of lies. You have to use your mind and your intellect to be able to correct that, because you can't trust your senses. They're constantly deceiving you. So the way that Zeno illustrates this is paradoxes concerning motion. The famous one is Achilles and the tortoise. How many people have heard of Achilles? That's right. Now Achilles is really fast. He's one of the Greek heroes. The tortoise is really slow animal, correct? Here's the paradox. And paradoxes are not contradictions. They're apparent contradictions. That's why they're so fun, is because we know it can't be. But it seems like a contradiction. Now I want to explain it. I have, as the Greeks would say, an aporia. I have a problem, and I want to resolve the problem. There's some sort of tension in my mind between one thing and another, and I need to resolve it. So the tension here is that I know Achilles is going to catch up to that tortoise in this race. Yet, according to mathematics and reason, he can never catch up. Now, according to Zeno's paradox, he gives, well, we've got to give the slow tortoises a head start. This just wouldn't be fair. Give the tortoise head start t. That distance, whatever distance you want. So the paradox is, okay, go. Now, when Achilles gets to point T, the tortoise has moved here. So we can say now Achilles is at A. The A stands for Achilles and T, tortoise. So as soon as Achilles gets here, the tortoise has moved a little bit. So, well, it should be fairly easy for Achilles to catch up. Sure. So once Achilles gets here, well, the tortoise wasn't standing completely still, so it moved a little bit. And he's going to try to catch up. Now, how many times can I do that? Infinitely. As long as he's moving, I can still add a smaller and smaller distance. So each time he catches up to the previous point, the tortoise has moved a little bit smaller point. So according to the mathematical reasoning is, no, Achilles never, even if you have an infinite amount of time, will never catch, he'll get closer and closer and closer, but never reach the tortoise. Isn't that? But you know that that's not possible, because if we put a tortoise in here and we raced and gave it a head start, we would catch up. Now, Zeno would say, that's because your senses are deceiving you. You're not moving. Why? Because everything's one. There aren't 2 points. So this is ways to kind of illustrate. The other one is the arrow paradox. Oh, here's a better way. If you want the actual mathematics, I put this up for you here. So the tortoise gets, let's say, one kilometer head start. Okay, so once Achilles, and the tortoise keeps moving. Once Achilles gets to 1 kilometer, the tortoise has moved a half a kilometer. So 1 plus a half. And then once he gets to 1.5 kilometers, the tortoise has moved an additional quarter of a kilometer, so on and so on and so on ad infinitum. So, according to mathematical reasoning and logic, no, Achilles can never actually catch up to the tortoise. Isn't that crazy? Yes?
You can only break it in half so much before, or you can only break it in half like infinitely.
Yeah, this goes back to mathematics and the concept of lines. If I have line AB, I can clearly divide line AB in half. Now I have line AC. I can divide line AC in half. So now I have line AD. And half would be an eighth. Okay, so E, AE. How many halves of a half can I take? Infinite. I can just keep going forever. But you didn't know that. You can divide a line infinitely. Let me show you another example of the arrow. You want to shoot this folio right here. Okay? But you can't because motion is an illusion. These are not the Jedis you're looking for. So, in order to get to him, you have to go at least halfway. Correct? It's the same concept. Now, after you get halfway, don't you have to go, well, at the very least, half of half, which is a quarter. Half of a quarter and an eighth. Half of an eighth, 16th. Well, same problem. Ad infinitum, it's like forever getting closer, but it's never reaching you. Like, well, this thing's never going to hit me because Zeno's right, motion is illusion, but then you get hit and you die. And you're like, paradox. I guess I'm not dead, but I really am. How about another one? So you can think about it in reverse. Because one way to look at it is that not only does the arrow never get to the target, it never even gets started, according to Zeno. How is that possible? Because, like I said, in order for the horse to get to point B from A, you're going to have to say at least the horse has to go halfway. I'll play the horse. We'll act out charades. Zeno's paradox. Well, before I can get halfway, if I was the horse, I guess it should be like this, huh? Before I can get halfway, I have to go at least half of that. Before I get quarter of the way, half of that, then I have to go half of that, an eighth of the way. So on and so on. Ad infinitum. So, can I even get to the first point? Well, do you know how many divisions between A and the first point there are? An infinite amount of divisions. You'd have to go through an infinite amount of points. So, Zeno concludes, there's nothing even gets started.
He says that you're already at point B.
The difference between point A and B is an illusion. If everything is one versus, if things were many, then A and B are not the same. But if everything is one, A and B are really the same, and we're just deceived in thinking that they're different. It's driving me crazy now. It's like a riddle. Some people like riddles, some people don't. And you don't like it because you can't figure it out, but I know the answer. No.
Come on, you're finished with class. How does
Aristotle solves this problem. That's your answer. And the way he solves it How many people remember in mathematics the difference between continuous and discrete? Discrete, as far as quantities or lines.
Continuous goes on forever, has the arrow. Discrete has lots of discrete.
Or discrete could be parts. For example, if I had a discrete magnitude of Lego blocks, I could divide them into the simplest parts, blocks. So I can't keep dividing infinitely. I divide down to the smallest parts, and then if I add up 20 Lego blocks, then I get 2 feet. That would be a discrete quantity. Also, film is discrete, but it's giving the illusion of continuous motion, because film is simply still frames, still shots. How do you get it to look like everything's moving? Yeah. How many people used to do the little doodle cartoon man? Isn't that great? So you draw still frames on there, and then what you do is you move it, and it looks like the little man's moving, raising his hand and waving at me. Okay, that's discrete motion. But continuous quantity or continuous motion would be something like, I have the line AB, and I can continually divide. So one is in terms, continuous is infinite division, discrete is composition. Here is the confusion. We're confusing the two concepts. Just because you can divide a line infinitely does not mean that it's composed of infinite parts. It's a failure to make the distinction between discrete and continuous. Yes, if I had a discrete magnitude, like the Lego blocks, I can divide that into parts because it's composed of the parts. But a line is not composed of an infinite amount of parts. The problem is, for example, if line AB, now a point has no part. In mathematics, a point is a breathless length. It marks extremities. So yes, I know I can divide the point here, the material point, but mathematics is not material, it's abstract. So when you define, as Euclid does in his Elements, who's the founder of geometry, a point is that which has no parts. You can't divide it. Therefore, it marks extremities. So you could say, rather than building up pieces, what you do in mathematics, let there be line AB. Well, how do you do that? Point A, point B, let there be fiat in Latin. Let it be. You create it. Now you can divide it by marking, using a point with another extremity. But if a point has no extension, since it has no parts, it would be absurd to think that, Aristotle says, as if it would be absurd to think like Zeno that a line is composed of an infinite amount of points. You can divide it infinitely, but it's not composed of an infinite amount of points or parts. Why? Because, okay, we'll try it. Okay, there's one point there. Now I'm going to add another point. Okay, another point. Now, am I getting any magnitude? An infinite amount of no extensions doesn't magically add up to, bling, oh wow, land of make-believe. It doesn't happen. So, what Aristotle does is he makes a distinction that all philosophers should. You're not distinguishing between continuous quantities, which can be divided ad infinitum, versus discrete quantities that are composed by taking units as parts and attaching them together. What you think about is the still frames that you're going through. Pretty nifty, huh? So paradox solved for now. Okay, so for homework, I am going to assign, how how many people have heard of Plato's Cave? We're going to read Plato's Cave, and then I'll put a document on Plato's theory of forms. Plato's theory of forms is going to solve the problem that was set up by Heraclitus. That if you can't, everything's in flux and change, that we can't know anything. Because knowing or trying to name something is to take like a still shot. It is. It is the tree. Well, now it's burnt down and it's not. So if everything's constantly changing, you can have no knowledge. It would be like a Lewis Carroll world of Alice in Wonderland where everything's growing and shrinking. You're trying to take and measure things, but your ruler keeps growing and changing. You wouldn't be able to measure anything. And likewise, with trying to measure reality, you need a arche, a ruler that doesn't change, so that you can apply that as a principle to. So this is what Plato is going to do. He is going to find a concept of something that does not change. And that will be the standard for knowledge. Sound good? Good. All right, guys. Have a great week, a great weekend.